Welcome to Brain Vision.
For this question, we want to compare the energy of a photon compared to an electron that both exhibit wavelength of 10 nanometers. So for an electron, it's quite easy to calculate the energy. It goes to hc over lambda. Wavelength is 10 times 10 to the power minus 9. This should give us energy of about 1.99 times 10 to the power minus 17 joules. On the other hand, for the electron, to get wavelength of 10 nanometers, it means that our momentum is equal to h over lambda. This by the de Broglie's wavelength. From here we can calculate what is the energy or kinetic energy for electron, which is given as p square over 2m. So substituting in the lambda to be 10 nanometers, should get our kinetic energy to be about 2.41 times 10 to the power minus 21 joules. Now the ratio that we need, or the ratio would be taking the energy of the photon over the energy of the electron, which leaves us with 8.26 times 10 to the power 3. So the photon is 8.26 times 10 to the power 3 times more or greater than the energy of the electron. Now, of course, this would mean that the photon is definitely more damaging than the electron. So the electron is the less damaging one, because it deposits less energy into our specimen, which means that there will be less ionization that could occur, and it would mean less damage. Right, so the electron is less energy,